Okay, we were taking another integral. This one's from the Vienna integration bee from 2024, problem 57. We have the integral of 1 over 2 sine squared x dx. Okay, I think there's actually quite a few different ways to do this one, but the thing that's sticking out, the thing that stands out for me is this is actually really close to 1 minus sine squared x, and for that we have the identity that 1 minus sine squared x is going to be just cosine squared of x. So in order to use this, what I can do is just take this 2, not very different. If I write this over here, 1 plus 1 gives us our 2. So this is the same as this. Let's add a 1 on both sides, and that's going to allow me to convert the denominator and write it as cosine squared x plus 1. But now from here, it's still not really clear what we do with it because we've got nothing in the denominator. So doing a u substitution doesn't look that great right now. But this is actually a good case where we can do the trick of multiplying in by secant squared x over secant squared x. Then we're just multiplying by 1, but that's going to work well because secant's just 1 over cosine. So when we multiply this in, first we're going to have secant squared x in the numerator. So now we have something in the numerator. Then multiplying secant squared times cosine squared, that's just 1. And then here we're going to have secant squared x. And now here what I want to do is we want a u substitution. And what I like is if the whole numerator can be my du. So if du is going to be this secant squared x dx, then the substitution that's going to work would be u equal to tan of x, just because if you take a derivative of tan x, you get back secant squared x dx. The only trouble is we don't have the tangent in the denominator, but we can create it. What we can do is we have the identity. We can use this thing, tan squared x plus 1 equals secant squared x. So if we just take this and plug it back in here for secant, then we'll rewrite everything and then we should be set up. So same numerator, secant squared x dx. Then if we plug this in here, we're gonna have tan squared x plus 1 plus another 1. This is gonna become tan squared x plus 2. But now that we have tangent in the denominator, we can go ahead and use this substitution over here to the right. So what's gonna happen is, again, the whole numerator is gonna be exactly this du value. Tan x is going to be u, so this becomes u squared plus 2. But for this plus 2, let's actually write this as square root of 2 all squared. And the reason I write it like this is to set this up. Now this is in our formula to use arctan. So this derivative, so what's going to happen, this will be like, in the formula, this will be like our a value right here. So integrating this using that formula, we're going to have 1 over square root of 2 arctan of u over square root of 2. But then all we need to do now is just back substitute in order to finish this off. And so for my final solution to this, we have 1 over square root of 2 arctan of this tan x over square root of 2, add a plus c, and that's it. Okay, there you have it. Good one from Vienna 2024. Thanks everyone for watching. Have a good day.